Hello guys, in this video I am introducing you to a new model, Cobra. Cobra extends the state space model Mamba to multimodal large language model for efficient inference. Cobra addresses the efficiency bottleneck of existing multimodal large language models that rely on transformers network with quadratic computational complexity. In this research paper, they have gone into way more detail about the architecture, settings, experiments, and lot of other information. I will drop the link to it in video's description. In this research, these researchers have explored the combination of language models with linear computational complexity and multimodal inputs. In terms of fusing visual and linguistic information, they have successfully optimized the internal information integration of the Mamba language model through in-depth research on different modality fusion schemes, achieving more effective multimodal representation. They have also done various experiments demonstrating that Cobra not only significantly improves computational efficiency but also performs comparably to advanced models like Lava, especially excelling in overcoming visual hallucinations and spatial relationship judgment. It even significantly reduces the number of parameters, and this really opens up new possibilities for deploying high performance AI models in environments that require high frequency processing of visual information, such as visual based robotic feedback control in the future. If you look at the architecture of Cobra, that is quite interesting. Here it is taking Mamba as a backbone consisting of identical Mamba block. So Mamba is on the right, whereas the Mamba blocks are on the left. The parameter of vision encoders are frozen during training. Now Mamba is a state space model. A state space AI model is a framework which is used in AI to represent problems as a collection of states, actions, transition functions, and rewards. Each state encapsulates a particular configuration of the environment. Actions denote possible moves that AI agent can make. Transition functions determine the outcome of taking an action from a given state, and rewards quantify the desirability of these actions. By navigating through this state space using techniques like reinforcement learning or search algos, AI agents can find optimal solutions or make informed decisions in a wide range of domains, from board games to robotics and beyond, as I mentioned earlier. In this architecture, to accomplish the purpose of building a multimodal LLM that is capable of receiving visual information, this Cobra has been released. It consists of three components: a vision encoder, a projector, and a Mamba backbone. Now, in the vision encoder, they have fused Dino V2 and SIG-LIP as their vision backbone. The intuition is that combining the visual representation, which capture low-level spatial properties from Dino V2 and the semantic properties provided by SIG-LIP, further improves the performance on downstream tasks. Whereas projector is a simple learnable module that aligns the feature of vision and text by transforming the dimension of original visual representation to the dimension of tokens. They have introduced two implementations of the different projectors in Cobra to map visual tokens into the same latent space as the language tokens. Also, lastly, the token will be de-tokenized to the response answer in the natural language. This model is also available at Hugging Face on this Hugging Face repo with Cobra from hand 1997. And another good thing is that they have also released this online demo which you can readily run now. Also, if you want to install it locally, there are also some instructions available on this GitHub repo, but you would need a good system with multiple GPUs in order to properly run this, as it is a multimodal LLM and quite big too. And these are all the instructions to run it locally. Let me show you how it works in this online demo. So I'm going to upload a couple of images and then we will try to chat with them. Let me load an image from my local system. I have added this image which is just an Australian outback. I'm just going to, and there are few kangaroos in this image. Let me ask it, count the kangaroos in this image. Let's see if it is able to identify the kangaroos and if it is able to count them. There are three of them, by the way, as you can see. Let's see. Let's wait for it to come back. And it has very correctly guessed that there are three kangaroos. Very nice. Let me try another image. I am going to ask it. This is an image of a Komodo dragon. I'm going to ask it, what is this animal in this image? Let's see if it is able to identify this animal. Okay, so it has identified that it is a lizard, but that is a generic thing. It is primarily a Komodo dragon. But anyway, let's try out another animal. It's a bear. Let's see if it is able to recognize that. What is this animal in this image and where it is normally found? So it is still fixated with lizard, it seems. So maybe I will just clear it and then reload that to see if it is able to find it. What is this animal? So it has now identified it that it's a bear, which is good. Let's try out another image. I'm going to identify the text. So I have just uploaded thumbnail from my own channel. So I'm asking it what is the text in this image. Let's see if it is able to identify text out of the image. Pretty close, I should say. The image says how to create synthetic data set with LLM locally, and it says how to create synthetic data with locally. So not exactly correct, but close enough. Okay, let's try another image. I am going to put an image of Australian outback. What location this image is from? Let's see if it is able to detect from unique red soil of Australia that it is outback Australia. Wow, very impressive. So it has detected that it is Australia. Any guess where in Australia? Very nice. Now it has said outback. So I should say pretty impressive model. Still, of course, early days, but for most of the questions, it was able to answer them. And I believe that this state space architecture is really cool. I already have done few videos around it in the past. That's it, guys. I hope that you enjoyed it. Let me know your thoughts. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps. Thanks for watching.